So we're going to graph quadratic functions that are in standard form today. So just to review, standard form of a quadratic trinomial is y equals ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot equal 0. So these are our steps that we're going to use to graph these quadratic functions that are in standard form. Make sure you write these in your notebook. If you need to pause the video for more time, you can do that. So our first step is to find the axis of symmetry. So to find the axis of symmetry when it's in standard form, we use x equals negative b divided by 2a. And then we draw a dashed line on our graph. So then after we find the axis of symmetry and draw it, we're going to find the vertex, and we find that by taking the x value from above and plugging it in, or substituting it in, to get the y value, and that gives us our point, x comma y. And then we're going to find the y-intercept and plot that. So if you're looking at a graph, our y-intercept would be a point where the graph goes through the y-axis. So to find the y-intercept, you plug 0 in for x. And our fourth step is we take the y-intercept and we're going to flip it or reflect it over the axis of symmetry. So that's exactly the same on both sides. So that, at that point, we should have 3 points. The vertex, the y-intercept, and then the one that you get from reflecting the y-intercept. So then connect those 3 points with step 5 to make that smooth curve or a parabola. So let's look at an example. We are going to graph this function, y equals 2x squared plus 4x plus 6. Remember, if you need more time, you can pause the video. So first we're going to find the axis of symmetry using x equals negative b divided by 2a. So our a value is 2 and our b value is 4. So we're going to plug them in. So it's negative 4 divided by 2 times 2, which gives us negative 4 over 4. So x equals negative 1. This is our axis of symmetry. So we're going to take our axis of symmetry and graph it on our graph using a dashed line that goes up and down. So let's go look at our graph. So where x equals negative 1, right here, we're going to do our dashed line going up and down. So this is our line, x equals negative 1. This is our axis of symmetry. It's always going to go up and down through the number that x is equal to. So in this case, it's negative 1. So now let's go back to our steps. The second step was to find the vertex. To do that, we take our x value from above and we substitute it in for anywhere that we see x in the function. So our function was y equals 2x squared plus 4x plus 6. So now let's substitute it in. We have y equals 2 times negative 1. Make sure you put it inside parentheses. Squared plus 4 times negative 1 plus 6. So at this point, you can evaluate by hand or you can use a calculator. Make sure you do it by hand to follow order of operations. And if you use a calculator, make sure you type this in exactly how it looks with the parentheses and the exponents. So we should get y equals 4 for our value. So that means the vertex was our x value, which was negative 1, and our y value, which was 4. So we're going to take our vertex and we're going to plot it on the graph. So it was at negative 1, 4. So negative 1, and 4. And that is our vertex point. All right, so let's go back to our steps. Next, we have to find the y-intercept. To find the y-intercept, you're just going to substitute x with 0. So our function y equals is going to become 2 times 0, because wherever you see 0, we're going to put, wherever you see x, we're going to put 0. So 2 times 0 squared plus 4 times 0, and then plus 6. So our y-intercept is going to equal 6. When we evaluate this, we got 6. So now let's graph our y-intercept of 6. So our y-intercept was positive 6, so we're going to put a point right there at positive 6. So let's look back at our steps. The next step says to flip the y-intercept over the axis of symmetry. And then we're going to connect the points, creating our parabola. So let's go back to our graph. So when we flip, we want to see how far away this point is from the axis of symmetry. So this point is 1 unit away from the axis of symmetry. So we're going to go 1 unit on to the other side. And then that's where we'll plot that point. So now that gives us those 3 points that we were looking for. So when you connect them using your curve shape, that's what our parabola should look like in standard form when we graph it. So let's look at another example. So our first step that you guys wrote down in your notes was to find the axis of symmetry using x equals negative b divided by 2a. So our a value is negative 1, and our b value is 2. So now let's substitute them in. So it becomes negative 2 divided by 2 times negative 1. So on top we have negative 2, and on the bottom we also get negative 2. So that means that our axis of symmetry is going to be x equals 1. So now let's go to our graph and make that dashed line that's going up and down through 1. So here's 1. Now let's make our dashed line up and down through 1. So this is x equals 1. So now let's go back to our steps. So we found the axis of symmetry. Now we need to find the vertex. So we find the vertex by substituting 1 in for x. So we have negative. That's going to stay on the outside. Only the positive 1 is going to go in parentheses. And then squared is on the outside. Plus 2 times 1. So all we did was replace x. It was originally that function. So in place of x, we put 1, making sure that this negative stays outside of your parentheses. So when you evaluate using either your calculator or by hand, we should get 1. So that means our vertex is at 1, 1. This was our x value, and then this is your y that we just found, because g of x is the same thing as y. So now let's plot that vertex on our graph. So at 1, 1 is our vertex. Let's go back to the steps. So now that we have the vertex, we have to find the y-intercept. So to find the y-intercept, we're going to substitute 0 in for x. Anywhere that we saw x, we put 0. So when we evaluate, we should be getting 0. So the y-intercept is equal to 0. So now let's go to our graph and plot that. So our y-intercept equals 0. So now, that next step says to reflect or to flip the y-intercept. So we need to count. Right now the y-intercept is 1 unit from the line, so we're going to go 1 onto the other side. And that gives us that third point. So now we're going to connect our points with a U shape. In this case, it's going to be upside down. But that makes sense because our function had a negative 1 in front of x squared, and we talked about that before. So that's our graphed function. So let's look at another example. This one's going to be a special case. So we have y equals 2x squared minus 3. The reason that it's a special case is because there's no x term in the middle, so there's no b. So first we're going to start out with that same step of finding the axis of symmetry. We're always going to do that. So x equals negative b divided by 2a. A is 2 and b is equal to 0. So now I'll substitute those values in, and we get negative 0 divided by 2 times 2, which is 0 divided by 4. So our axis of symmetry is 0. So now let's go to our graph and plot that. So our axis of symmetry is just going to be right here, right where the y-axis is. So now let's go back. So since this is a special case, all we're going to do is make a table. And that should be your go-to in case you ever get stuck. But you always want to do this first step because that x value is going to go in the middle of your table. So we're going to put our x value of 0 in the middle of the table. And then we're going to go up to numbers and down to numbers. So I go down to, I go negative 1, negative 2, and I go up to 1, 2. So we're going to substitute those values into our function. You can use your calculator. Just make sure that you are using your calculator and having it typed in exactly how it looks. So this will become 2 times 0 squared minus 3. So when x is 0, y is going to be 3. So that can go into our table. So 2 times negative 1 squared minus 3. So here it should be getting y is equal to negative 1. And then we can do 2 times negative 2 squared minus 3. Make sure that if you are using your calculator, the negative is inside the parentheses and the exponent is on the outside. So this should give you a value of 5. So here we have 5, and then this one was negative 1. So those values are going to be the same on the other side of the table also. So that's what we're going to use to make our graph. Just going backwards, this should have been negative 3. So make sure you fix that. It should be negative 3. So add that negative sign. Sorry about that. All right, so now let's take this table and use it on our graph. All right, so looking at our graph, let's write that table down again so we can use it. Okay, so we have 0, negative 1, negative 2, 1, 2. And then in these values, we had 5, negative 1, negative 3, negative 1, and 5. So now you're just going to use those points in your graph. So I have the coordinates negative 2, 5. I have negative 1, negative 1. I have 0, negative 3. I have 1, negative 1. And then I have 2, 5. So let's plot them. Negative 2, positive 5. Negative 1, negative 1, 0, negative 3, 1, negative 1, and 2, 5. That should give you that U shape. And there's our parabola. So let's look at another example. This is another special case, and the reason it's a special case is because the y-intercept most likely will go off your graph if you're given a graph to make your parabola on. So we're going to make a table again, but we still want to start out with finding our x, our axis of symmetry, to get the x value. All right, so our axis of symmetry is x equals negative b divided by 2a. So our a value is 2, and our b value is negative 16. So now let's substitute. Negative comes from the formula, and then our b is negative 16, so we need both of those signs there. And then 2 times 2. So on top it will become positive 16, and on the bottom we get 4. So our axis of symmetry is x equals 4. So now let's plot that on our graph. So our axis of symmetry was x equals 4. I'm going to go to 4 on the x-axis, and our line's going up and down. So that's our line x equals 4. So now let's find the vertex. Or you can make a table. Either way is okay. So if I just go right to the table, I want to put my x value in the middle. So in the middle, I'm going to put 4. And then I need to go 2 numbers down. So I can go 4, 3, 2. And then I want to go 2 numbers up. 4, 5, 6. And I'm going to substitute those values in. So y is going to equal 2 times 2 squared minus 16 times 2 plus 33. So we should get y is equal to 9 in that case. So now let's get another. If we plug in 3, 2 times 3 squared minus 16 times 3 plus 33. So with that, we should get y equals 3. So let's plug in 4. So y is going to equal 2 times 4 squared minus 16 times 4 plus 33. So in this case, our value for y should be 1. So I'll put 1 over there. And then they're going to repeat themselves as long as you pick 2 numbers above and below the x value. So that's going to be 3, and then this one will be 9. So now let's take this table and use it to make our graph. So we've got x and y. Using this table to make our graph. So our x values we used were 2, 3, 4, 5, and 6. Remember, we picked 4 because that was our x value, and then we went 2 below and 2 above. So then our numbers for our y's were 9, 3, 1, 3, and 9. So now let's plot those points. So 2, 9, that's going to go off the graph, so let's go to 3, 3. And then 4, 1. And then 5, 3. So that gives us our U-shaped parabola. And that's it.